from this diagram. So let's presume that you don't know what is PLL. Here we'll quickly cover that. Here is an input signal with a voltage Vi, frequency Fi given to a phase detector. So the input signal Vi with an input frequency Fi is passed through a phase detector. A phase detector is basically, as I mentioned, nothing but a comparator which compares the input frequency with the feedback frequency. Feedback is, this is nothing but my output, correct? So output voltage and output frequency. So what is a phase detector going to do is, it's going to compare my input frequency with the output frequency. We want that my input frequency to be same as my output frequency, correct? We want that. So the phase detector will basically compare this and it will produce an error voltage at the output. If there is a difference, it will produce some error voltage at the output, which we'll call it as VER, which is nothing but a DC voltage. This DC voltage is then passed to a low pass filter. Why do we need a low pass filter? The low pass filter will remove the high frequency noise and produce a steady DC level. See, the phase detector, which is nothing but a comparator or an XOR gate, compares the input frequency with the output frequency. We want technically both of them to be same. If they are not same, it will produce an error voltage, which is nothing but a DC value. This DC value needs to be passed to a low pass filter because it will remove the high frequency noise from there and produces a steady DC level. And this DC level is then passed to a VCO. We just now saw that low pass filter producing a V adjust, which goes to a delay line. With now you will understand very clearly, this is nothing but a voltage controlled oscillator. The output of the low pass filter goes to the voltage controlled oscillator, correct? This is some DC value which is going to a voltage controlled oscillator, and the output frequency of the oscillator FO is going to be directly proportional to the voltage which is applied to. So here both the input and the output frequency are compared and adjusted through feedback loops until the output frequency equals to the input frequency. I think very straightforward, right? We want Fi to be equal to Fo. For that we need to identify whether they both are same or not. In order to identify, we'll need some comparison circuit or a comparator. Here what we are going to compare is nothing but phase, so we will call it as a phase detector. This will compare if Fi and Fo are same or not. If not, it will produce an error voltage. This error voltage is nothing but a DC value which will have noise as well, so we need to eliminate that noise. So we pass this to a low pass filter. It eliminates the noise and gives us a steady DC value. Once I have the steady DC value, I give this voltage to a oscillator, which is nothing but a voltage control oscillator, which will produce an output depending on its voltage, which is nothing but Fo, and it will ensure that, see, the low pass filter has produced a voltage corresponding to the error voltage, right? So this voltage, which is going to the voltage control oscillator, will change the frequency of oscillation and it will try to map it to its error voltage such that Fi is equal to Fo, and this is the basics of PLL. Now let's see how this is used for clock stabilization here. So here I have my external clock. It is given to the PLL. PLL will ensure that my external clock and my clock which is ready, correct, to go to my chip. Don't get confused. You can take it after the buffer, you can take it before the buffer. If you take after the buffer, your signal strength would be restored. If you take before the buffer, there is a chance that you might use your signal strength. But here we are not talking about the signal strength, we are talking about frequency. So you can take the output from here also. Don't get confused with the two diagrams. Understand this, that PLL is present here. It is comparing the external clock with the internally generated clock from here, because this is going through a clock generator, right? So if you see it independently, it's this way. My clock generator, we want to stabilize our clock, right? This is my internal clock. There is some external clock. We want the frequency of this external clock to be equal to the frequency of this internal clock. So we give this to some comparison circuit or comparator circuit. In our case, we are going to give this to PLL, which itself will compare internally through a low phase detector or a phase detector circuit. Not a low phase detector, I meant a phase detector circuit or a comparator. It has it internally. Corresponding to that, it will produce an error voltage which will go and be given to our low pass filter, which will remove the high frequency noise, and a steady state DC value would be at its output, which will be given to my voltage control oscillator, which will ensure that my input voltage frequency and my output voltage frequency is same, and that correct frequency will be given to this clock generator circuit, and hence my problem of clock is resolved, or hence I could achieve the stabilization of my clock. This is how clock stabilization is achieved with the help of PLL. This is my buffer chain and this is my clock which is going to my chip. Hope you have followed clock stabilization. Stay tuned for further clips and thank you very much.